All right, so we are in Chapter 1, Section 3 for IM2 called Multiplying Polynomials. So we've practiced adding and subtracting polynomials, and we've practiced multiplying a polynomial times a monomial. So now we're going to do two polynomials. So to multiply two binomials, the distributive property is used. Binomials can be multiplied horizontally or vertically. So here's our first example here, and it shows us two different methods. So if you notice, it's the exact same problem. We're just going to look at it in two different ways. So first, we're looking at it vertically, which means, top to bottom, up and down. So if you notice, they have it stacked here. So we have 2x plus 3 times x plus 5. And then they have it stacked here. So we have 2x plus 3 and then times x plus 5. If you notice, this is the only one of the terms that's in the color black for the font. And then what they want you to do for a moment is basically ignore it. They want you to focus in on this first one. And what I want to make a point of is this vertical method is just like multiplying two-digit numbers. So if I have, let's say 22, and I wanted to multiply by 12, you know what? I'm going to use some different numbers. So I don't want to use exactly the same numbers. Let's go 13, just so that it's not a bunch of 2's. And I'm multiplying these numbers. I'd go 3 times 2, and I'd get 6. And then I'd go 3 times 2, and I'd get 6 again. So that's what they're doing in this first step. This ones column, basically that's what the 5 is. So they're going 5 times 3, and they're getting 15. And then they're going 5 times 2x, and they got 10x, because 5 times 2 is 10. And we only have 1x. And then in the next step, they're basically looking at the tens column. It's not truly ones and tens, but it's kind of a nice way to look at it this way. So now, if I were to look at this one, and I'm going to write it just in a different color. So we already have the 66 here, right? So now the next step, we want to focus on this 1, and we go 1 times 2. Instead of writing it down here, you wouldn't write it there. So we learned this when we were in grade school, when we were learning to multiply. We actually write it under the column that we're multiplying by, right? So we would learn to put like an X or a 0 or some kind of placeholder there just to let us know we're not multiplying that column, we're actually multiplying the tens column. And then I go 1 times 2 and I get 2 again, right? And then I can add these two columns together to get my total number. So this is 22 times the ones column of 3, and this is 22 times the tens column, right, of 10. So that's why we get 22, and if we were to put a 0 here, you'd actually see it's 220, but I think most of us learned to put an X there just as a placeholder. We can add straight down, so X plus nothing would be 6, 6 plus 2 would give us 8, and then 2 plus nothing up here would give us 2. So we get a total answer here doing it this way. So same thing, we're going to do that for this next one. Now we're going to focus on the tens column, or the second number. So x times 3, we get 15. Oh, sorry, looking at the wrong one. X times 3, we get 3x. And if you notice, it came straight down. It's underneath where I'm multiplying here, so it's lined up. So this first one, I was starting with the 5, and it came right under the 5, and that's where we started. And then 5 times 2x came straight down, and it's right here. But we're starting with this x, which is in the second position, so my answer starts in this second position. There's nothing here. So in like this example where I was doing 22 times 13, this would kind of be like an x or a 0 or something along those lines. We wouldn't write there, or we wouldn't have a number filled in there. And so we have x times 3, and then we have x times 2. So that would be 2x squared, because remember there's a 1 in the front. 1 times 2 is 2. This is x and x, so there's 2 x's. All right. Now the third section just shows us to combine like terms, and as long as we've lined up the columns correctly, really the only like terms should be right above each other. All righty? So all we have to do is add straight down, and we get our answer. So 15, because there's nothing underneath it, 10x plus 3x gets us 13, and then 2x comes straight down because there's nothing above it. All right. So now let's look at this exact same example, but we're going to go horizontally. So we're going to go from side to side. And what I want you to notice on this one is what they're doing is they've color-coded these 2x and 3. So they're focusing on this first one. These are our multipliers. And what they did was they're multiplying this whole thing by 2x. And then they're multiplying this whole thing again by 3. So they separated out these two pieces is what they did. All right. So they're just taking that first one, and those are our multipliers, and they're using this second one as many times as we need to. In this case, since it's binomials, we should only have to do it twice. Because remember, if we break that apart, binomial means two numbers. And then we just go through and multiply. So they distribute. 2x times x gets us 2x squared. 2 times 5 gets us 10x. 3 times x gets us 3x. 3 times 5 gets us 15. So we distribute those numbers, those multipliers, and then we combine the like terms, which again here are in the middle. So we end up with 2x squared plus 13x plus 15. Again, we ended up with the same answer, right? These two answers are exactly the same. I'll put a box around them. It just depends on the method that we like the best. Okay, so let's go ahead and look down here at this a little bit in practice. All right, so I will do this one vertically and I will do this one horizontally. So we have 5x plus 2 times 5x minus 2. And we're multiplying. And again, they put this in parentheses when they do it this way so that you know it's not x as in a variable. It's x as in multiplication. And they did the same thing when we were subtracting or adding. It's just a way to identify it's an operation as opposed to a variable, okay? Or a positive or negative sign when we're adding or subtracting. All right, so we're going to go ahead and use the ones column, and I'm calling it the ones column just to kind of relate it that way. So we have negative 2 times 2, negative times a positive, we get negative, 2 times 2, we get 4, and then negative 2 times positive 5x, so again it's going to be negative, because negative times positive, 5 times 2, we get 10, and then there's only one x here. All right, let's see, I'll go with gray for this next one. So now we're going to move over, and I'm not doing it in 3 separate pieces here. I'm going to do it all in one piece just because I don't have a lot of room. So 5x, I'm moving over to the next piece. I've done negative 2x. Now I'm going to go 5x times 2. Well, remember, I'm going to write it right underneath here. This is where I'm starting. So I have 10x, and then 5x times 5x, I have positive 25x squared. Sorry, that was a positive 10x. All right, so I'm going to go back to blue here, just kind of finalize it, since that's what I started writing with. And we're going to add straight down. So there's nothing underneath here. It's going to be negative 4, negative 10x plus 10x. Anything minus itself is 0. So one's negative, one's positive. They are exactly the same. They actually cancel out, and they go away. You can write plus 0 here, but when you write it in ALEKS, it's going to expect you to simplify this. So we'll go ahead and write it this way, but it's going to expect you to simplify this to just 25x squared minus 4. This is actually a special multiplication product, and we will talk about this in some of the next sections. But this is called a difference of squares because they're exactly the same. The only difference is this plus, this minus. But we'll talk about this again in another section. So, but this is one of those special circumstances because the middle terms disappeared. All right, let's go ahead and do this guy horizontally. So here are my multipliers. I'm going to use x and 3. So I'll go ahead and do x. I'll do it the same way they did it. So I'll start with x is red. And then I'm going to multiply that by 2x minus 3. Plus, and I'll do this in blue, negative 3 times, 2x, I'm going to erase that. Sorry, forgot the 2. 2x minus 3, like that. All right, so my multipliers were x and negative 3, so we can see that. Here's x, here's negative 3. I separated them, and I'm multiplying by the entire 2x minus 3 by the entire 2x minus 3. So now I'm going to start distributing them, and I'll go ahead and just do this in black. Why not? So I'm going to distribute x times 2x is going to be, remember there's a 1 here, so it's 1 times 2 is 2. X times x is x squared. X times negative 3, so it's 1 times negative 3, so it's negative 3. And then just x, because we don't have anything else to combine that with. And now we have plus negative 3 times 2x, so negative times positive, we get a negative 6, and then x, because there's nothing else to combine that with, so it's just 1x. And then we have negative 3 times negative 3, so 2 negatives make a positive when we're multiplying, and 3 times 3 is 9. All right, we have to simplify this a little bit more because we have some like terms here in the middle. So Alex will expect you to do that. It might even warn you the first few times that you try this. If you were to type this in exactly this way, it's going to tell you it's not simplified. After the first, possibly the second warning, but I think it might even be just after the first warning, it'll just go ahead and mark you wrong if you're not paying attention. So make sure you combine like terms before you enter. It should be all completely simplified. So negative 3x plus negative 6x, they're both negatives. So I already have 3 negative. I'm going to go 6 more negative. 9. So negative 9x plus 9. So I can't combine anything else because remember nothing else is a like term. X squared is different than x. All right, so these are not like terms because one has a square and one doesn't. And then these are not like terms because one has a variable and one doesn't. So you have to be careful with that. All right, let's go ahead and go to the second page. This guy has 2 pages. So just another method for multiplying. And I'm going to scooch up here because I believe there's a little example at the top. So this is just using the FOIL method. If you've never used the FOIL method, which most students at this point have heard of it, it's just a way to help you remember to multiply all the pieces of a binomial times a binomial. This only works for a binomial times a binomial. All right. So what it means is first, outside, inside, last. So that's what FOIL stands for. If we go like this, FOIL, we have first, outside, inside, last. Well, what does that actually mean? So you can kind of see what they're doing here. So first means the first term in each set of parentheses. So x times x. Outside or outer means the farthest to the outside for both. So I have x and I have negative 2x. Inside means the two that are closest to the inside there. So I have 4 and x. And then last means the 2 last terms in each. So it's referring to the positioning is what it's doing. And it's just a way, again, to ensure that you have multiplied all of the pieces. So let's go ahead and we're going to kind of skip down here because they give us another example. But I wanted to show you, so they actually give us the same problem here, but let's go ahead and look at this one. So we have 5x. I'm going to write it up here so I have more room. Here, I'll pick a different color so it's easier to see. 5x plus 2 times 5x minus 2. All right, so first we have 5x and 5x. So that's 25, because 5 times 5 is 25. X times x is x squared. So that's my first term, because it's the first thing in both. Then I have outside. So outside would be the farthest to the outside. So really the first thing and the very last thing. So 5x times negative 2, and you're multiplying these terms every time you see them. So 5 times negative 2, you get negative 10x. And then I'll go with gray here. So now we have inside. So we just want the ones that are, closest to the middle here. So we have 2 and we have 5x. So 2 times 5x, we get positive 10x. And then the last one here, I guess we'll do it in green. It might be a little bit bright on your side. Sorry about that. But we'll just different colors. So the last term is going to be the last things in each. So we have 2, that's the last one, and then negative 2 here. So 2 times negative 2, and we get negative 4. So now we want to make sure we combine our like terms, and we have 2x squared, negative 10x plus 10x, just like it was on the last screen. They cancel out, so we just have negative 4. So we get our answer here. What I wanted to show you on this second one, though, was what we call the box method. Some students really like the box method. There's also the diamond method. There's a bunch of different methods to do this with. But I like the box method because it's a little different. It's kind of a visual representation. So you draw a box like this. And then you put your binomials on it. So I have x minus 3. What I like about the box method is it will work for things bigger than a binomial. You can use this for any size polynomial you would like. You just keep adding sections to it. So you draw a line where the addition or minus sign is. And then you do the same thing here. So I have x minus 3. Actually, I'm going to put the negative 3 on here, because remember that negative actually belongs to the 3 here. And then this is where the separator is, where we want the monomials, basically. That's what we want on each piece. So we're taking the binomial and we're kind of separating it out into pieces again. And use this just like you would a multiplication table. So if you remember, back in grade school when we had the multiplication table and we could use our fingers, going from the top and the side, we could go, 2 times 3, and we could follow our fingers down to, get 6. And hopefully we can picture that in our heads. I know you can't really see. I'm not showing you what it looks like. I'm just telling you, but it's kind of like using a multiplication table. So it's exactly like using it. So you go down and you go over. So I bring this down and I bring the side over. So x times 2x, I get 2x squared. And then I keep bringing this down and I bring this one over. So I bring it down, x and negative 3, so we get negative 3x. And now we move over to this negative 3. Remember, that negative belongs to the 3. So I'm going to bring it down, and I'm still bringing this one over. I'm just moving to the next column here. So negative 3 times positive 2x, we get negative 6x. And then I keep bringing this one down, and I bring this one over. So I have negative 3 times negative 3, and I get positive 9. One nice thing about this one is that as long as you have these in the correct order from greatest to least, the like terms should be in the middle here, meaning going from the bottom left up, if there's a diagonal, those are like terms. So if there is no diagonal, it just means that it has nothing to combine, so just 2x squared, negative 3x, and negative 6x, I would combine these and get, not positive, I don't know why I changed it to a positive, negative 9x, and then plus 9, because there's no diagonal here. So again, no other like term. So this was the same answer we received on that first page. So if you notice, those were the same problems. We had the same answer. It's just, clicking on the wrong stuff here. Just a different way to do it. And I wanted to show you the box method because that's just yet another way to multiply a binomial times a binomial. Alrighty. I will see you in section 4.